example using the quadratic formula. So this is our quadratic equation. It is not in standard form, therefore we have to rewrite it. So if we just add 7 to both sides, then we will have 3x squared minus 2x plus 7 on the left. That equals 0. So everything is on the left side. Now our equation is in standard form. So we can just find the values for a, b, and c. So a is 3, the first coefficient, b is -2, and c is the constant term, which is 7. Okay, so we write our quadratic formula and we plug the values of a, b, c into this formula. So after we plug these values in, we just evaluate its value, we simplify the expression, and what we get inside the parentheses is that we get -80 inside the square root, So we need to find the square root of -80. So this is a negative number, therefore we will end up with a complex number. So we can factor 80 as 16 times 5 times -1. So since it is negative, we have to factor out a -1, and for 80, the largest perfect square, which is a factor of 80, is 16. Therefore, we can factor it as 16 times 5. Now, we can we can just split this as square root of 16, square root of 5, and square root of -1. So the first one will give us 4, square root of 5 will stay as square root of 5, and square root of -1 will give us I, the imaginary number, imaginary unit I. So we just replace the value of the square root of -80 with 4i times square root of 5, and we copy the rest. So we have 2 plus or minus 4i square root of 5 divided by 6. Now here the numerator can be, so we can factor out a 2 in the numerator. We can also divide the denominator by 2. So if we divide the numerator and denominator, by 2, so if we divide both by 2, we will get 1 plus 2i times radical 5 divided by 3. So here, since it won't simplify further, you can just leave your answer in this compact form, or you can just, if you're asked to write them separately, you can split it in two with these pluses and minuses. You can just write them separately. So we have two complex solutions to this equation.